our final ANOVA for the answer packet, okay? So now, what do we got? Copy. Paste my data. Label my variables. Part. Emotion. So I used a emotion manipulation condition for some reason. I don't know why. Why did I switch it up? I don't know. I don't know why I switched it up on y'all. So new data. Maybe I was getting tired of the data. 1 cup, 5 cup, 10 cup. I'm going to be lazy. 1C. 5C. 10C. Continuous. 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 No big deal. All right. So now, this is the only mixed design I'm going to give you in this analysis. One participant, they're in one of two conditions, right? You get multiple responses from the participant, but they're only in one of the conditions of another independent variable. So we see here participant A is in the anger condition only, participant E is in the happy condition only, right? But then they give us, we have them drink 1 cup in the anger condition and report their happiness. Drink 5 cups in the anger condition, report their happiness. 10 cups, report their happiness. Let's see what we find. Okay. So ANOVA, repeated measures ANOVA. Even though it's mixed, there's no special mixed ANOVA. The repeated measures factor is coffee again. Level 1 is 1. Well, actually level 1 is 10. Level 2 is 5. Level 3 is 1 because I believe 10 cups will lead to more happiness than 1 cup. I just have to drag my variables into the repeated measures cells down here. 10 cups goes in 10 cups. 5 and 5, 1 and 1. And then I get my between subjects factor of emotion. Sometimes it's just not user-friendly, but I got it in there. I finally got it in there. Partial eta squared. Dependent variable is happiness. That's cool. I didn't see that last time. I missed that last time, but that's fine. That'll just make the outputs easier to read. So let's just kind of get a sense of what we found here. The main effect of coffee is significant. The coffee by emotion interaction is significant. And the main effect of emotion is significant. So if you look, the between subjects effect is down here, and the within subjects effects are up here. When I'm getting the 95% confidence interval, or the 90% confidence intervals of eta squared, I need to use the within subjects one up here, and the between subjects one for down here. I like to do it one effect at a time. Let's go ahead and do the emotion main effect. For the main effect one, the 2 level, which mean is larger? Well, in order for me to do that, I got to look at my estimated marginal means, put my coffee over here, or put my emotion over here, excuse me, and see that those in the happy condition are happier than those in the anger condition. That makes sense. Happy greater than anger. That's good. Is this a significant mean difference? Yes, it is. Why? Because it is a significant main effect. That makes it a significant mean difference. Yes. What is your best estimate of the population mean difference? I do not know yet. This is a between subjects effect. So I have to go to, right now I'm on the within subjects calculator. Still within no, this is the between subjects calculator right here. So now I need to pull my F, which is 14.22, no, but it's 25.6. That's my F statistic. Degrees of freedom 1 is 1. And degrees of freedom error, degrees of freedom 2 is 4. It's right underneath it. 1 and 4. My N, I'm going to actually go back to my data and just count, right? Because there are 6 participants. Good. My N is 6. There are 6 participants. We run our command here. we look at it. Let's see if this makes sense. It sure does. Our lower limit is 31. Our upper limit is 92. Let me get those in there. 0.31, 0.92. Both of those are large, too large. Write your statistical sentence for this main effect. I've got a bunch of statistical sentences in here. Let me just go ahead and copy this one. All right. Put it in there. So F with, gotta go back to Jamovi here. F with 1 and 4 degrees of freedom is 25.6. F with 1 and 4 degrees of freedom is 25.60. Yep. P value is 0.007. Partial eta squared is 0.87. And the population effect is between 0.31 and 0.92. And these are both large to large effects. Perfect. Headline for this main effect is, the happy manip makes people happy. Really doesn't matter. Like, that's what it is. That's all it is. So now we go to our 3-level main effect. Let's go ahead and look at the picture so we know what's going on. Go to my estimated marginal means, get these out of there, get this one in. Coffee goes in. What do I see? I see that the same thing I've seen the whole time. 10 cups of coffee makes you happier. So list your means from smallest to largest. 1C, 5C, 10C. Is this a significant ANOVA effect? Yes, it is. We saw that earlier. Let's go see it again. Coffee, main effect of coffee. P-value is less than 0.05. That is significant. Yes. What is your best estimate of the population effect size? So this is my within subjects effect. So when I go here, I need to use my within subjects calculator. I have them both up, right? But let's go ahead. Our F for coffee is 19. Our degrees of freedom for coffee is 2, and our degrees of freedom error is 8. You'll notice again my data laziness and my made up data has made it so that the interaction and the main effect of coffee have the same exact values, but that's not always going to happen. That'll probably not happen again for y'all, but that was just to make everything a little bit easier on all of us. So if you see a pattern, it doesn't mean it's a pattern. It could be a coincidence, or it could be that Dr. D is lazy. Both those are fine. The 90% confidence interval of eta squared is from 0.43 to 0.88. Oh, 0.44 to 0.88. I made a rounding error. 0.44 to 0.88. Well, that's large to large, large to large. Write your statistical sentence for this effect, no problem. You don't have to have the large to large on there, that's just notes, so that would go away. So F with 2 and 8 degrees of freedom equals 19 right there, you can see it, 19.00. P-value is less than 0.001. Partial eta equals 0.83, with the 95% being 0.44 to 0.88. Large to large. Run the post hoc test here, no problem. Go to my post hoc test, throw coffee in there. Get my Tukey's test here. We're not getting 95% confidence intervals, 10 versus 5. Do I got the table? Sure. 10C versus 5C. That was my first comparison that they did there. Has a T of 3.46 and a p-value of 0.055. Not significant. 10 versus 1. 10C versus 1C equals 5.00. We can see it's significant because it's 0.016, so that is significant. And then we have 5C versus 1C. That one has a t-value of 4.00 and a p-value of 0.035. That is significant. Headline for this main effect is drinking 10 cups of coffee leads to more happiness than 1 cup. Drinking 5 cups of coffee leads to more happiness than 1 cup. Drinking 5 or 10 cups appears to be the same. So I would say drink 5 or more cups of coffee to maximize happiness. There we go. That would be my summary of that. That's like the summary, right? You don't have to have all that. This right here works. Either of these work. I was just processing the data. All right, my interaction. We are at our last effect. I am losing steam, y'all. That's fine. Let's look at our picture. I want to look at the 3 slopes, right? We have a significant interaction. We do. We can see that it is significant, right? Draw your interaction 3 slopes. There we go. Just to describe it, when you have 10 cups of coffee, the anger manipulation did not have any effect on happiness. If you drink 5 cups of coffee, the anger manipulation reduced happiness. And if you drink 1 cup of coffee, the anger manipulation reduced happiness. That's what we're seeing there. That's draw your interaction slopes, describe your 3 slopes, right? I would say like drinking less than 10 cups or the anger manipulation appears to have no impact when you drink 10 cups, but reduces happiness when you drink less than 10 cups. That's what I would say. Is your ANOVA effect significant? It sure is, because this is a significant interaction. P is less than 0.001. What's your best estimate of the population effect size? Well, because I made it easy on myself, I'm not going to have to redo everything. It's still 0.44 and 0.88. Look, all our numbers are the same. Same F, same degrees of freedom. That's all we need to plug in. So we know that the population effect is between a large and a large effect. Okay? Because partial A squared, 0.01 is small, 0.06 is medium, 0.06 is medium, 0.14 is large. All right, so this is large right there, large to large. Yes, you heard my descriptions. Write your statistical sentence for the interaction effect. One of the greatest parts of me setting it up with the very similar data across the conditions is I don't have to really, I have the same sentence there, so that's totally fine. And then finally, run your post-hoc, but only look at the 3 t-tests that are examining what you care about. This is less for me and more for other professors. So then we're almost done, y'all. We're almost done with the whole packet. Right? 10 cups of coffee, anger condition. 10 cups of coffee, happiness condition. The mean difference is essentially 0. The t statistic is essentially 0. The p is 1. So 10 cup with versus 10 cup. 10 cup anger versus 10 cup happy versus 10 cup happy. manipulation equals, has your t equals basically 0.00, and your p-value equals 1.00. So we got 10 cup versus 5 cup. Oh, I'm sorry. That makes no sense. 5 cup angry versus 5 cup happy. So now let's find that one. So this is 10 cup angry. This is 10 cup happy. 5 cup angry, 5 cup happy. The T statistic is 4.24. The negative's not going to matter here. This is in line with my predictions. It's 4.243, and the p-value is 0.072, so that's non-significant. So that would, the T, if you're making that table, equals 4.24, and your P equals almost significant, but not 0.072. And then 1 cup angry versus 1 cup happy. T, I can see it, but I'll show you. 1 cup angry versus 1 cup happy. Your T statistic equals 7.07. You can write it as negative as well. Those are both equally right, but I'm just hitting a wall here. 7.07 with a p-value of 0.012. All right. I'm still describing what's my headline? I didn't ask for the headline. My headline for this interaction is that drinking less than 10 cups makes one susceptible, drinking less than 10 cups makes one's happiness susceptible. How would I describe this? Okay. Under most circumstances, an anger manipulation reduces happiness relative to a happy manipulation. However, for people who drink 10 cups, anger manipulation has no impact. I'm not writing it here. That would be my headline. People who drink 10 cups of coffee have a happiness that is unaffected by a traditional emotion manipulation. Happy versus angry, all right? But people who drink less show the expected response. It's possible coffee harms our emotion responses. Okay, that is the end of this video. We are done, friends. We are out of here.